Whoa, 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 whoa. Okay, we're doing lost signs day 2, and we're looking at the ambiguous case, but it's not terrible, and it should make a lot of sense. Well, it should make some sense. There's just a quick comment I'm gonna make, and then hopefully you're like, oh yeah, that should make sense. That should make sense. But suppose I had sine of 15 degrees, and I don't really care like what the value is. Like I don't want to use half angle or angle addition to actually figure that out. But if I were to draw this, sine of 15 degrees is approximately here, right? And then we can make this right triangle, and this would be a unit circle, and this y value would be the sine value because sine is y over the hypotenuse. But because sine is positive in the second quadrant, like this triangle, all right, like it's like symmetric triangle here, where this reference angle is 15 degrees, would also have the same y value. It would be indistinguishable. And I guess what I'm trying to say is sine of 15 degrees and sine of, I don't know what that works out to be, 165, sine of 165 degrees would have the exact same value. Maybe I should have took a unit circle value, say sine of 30 degrees and sine of, I don't know, 150 degrees. They would have the same value because like sine is positive in both those quadrants. And whether you're in the first quadrant or the second quadrant, I mean, that's less than 180. Now, the sum of the interior angles of a triangle is 180. So there is a possibility that the angle we're looking for is in the second quadrant, or the angle works for the first and second quadrant. So you're going to have like multiple answers, a possibility of having multiple answers when you're solving for the angles and you're using law of sines. And let's see here. All right, our first example here, our first problem. A is equal to 5 and C is equal to 7. And the measure of angle A is equal to, A is 42 degrees. 42 degrees, I got this. A is equal to 42 degrees. And we want to find the measure of angle C. C equals question mark. And so I'm going to do sine of 42 degrees over 5 is equal to sine of, not really sure, of 7. And then I'll solve for sine of C. Sine of C is simply 7 times sine of 42 degrees divided by 5. I'll do the inverse of this. C is equal to sine inverse of 7 times sine of 45. How did that turn to 45? This should have been 42. 42 over 5. And then I'll plug this into Desmos. I'll bring up Desmos real quick. And hopefully we know what we're talking about, maybe. All right, so here's Desmos. Let's see, 7 times sine of 42. 42. And 5. Okay, perfect. I got 69.5, so C is approximately 69.5. Okay, so that's one possible angle. And we're just solving for C. Okay, so we could do that. So the other one is going to be, our other C value is going to be 180 minus 69.5. And when I do this, let me do this in Desmos because I'm not trusting myself right now. 180 minus 69.5, I simply get 110.5. 110.5. There we go. There we go. And I can show you, I can like make this triangle, right? So here's my two possibilities. I'm like checking my work. A was 42. And in this case here, C is 69.5. C is 69.5. And then I can figure out what B is. I add those together, 100 and something, and then B is going to be like 70 something or something. I don't know. Can't think right now. Maybe 60 something. And then on this one, we'll have C is equal to 110 and A is equal to 42. and that gives you 152. So B turns out to be the angle of 28 point something. So basically, there's not enough information to answer this completely. So we have two possibilities. Two possibilities. It's not bad. It's not bad. It's not bad. All right. I'm going to continue. All right, let's see. I want to double check the answer. Make sure I got it right, though. Double checking the answer. Law of Science, day 2. 69 or 110. Okay, perfect. It was actually 110.5, but sounds right. All right, on to number 2. Same. It just seems very similar. A is equal to 15, and B is equal to 20. And we want the measure of angle A, or measure of angle A is equal to 40. And the measure of angle B is equal to question mark. I mean, same setup, you know. Sine of 40 over 15 is equal to sine of B over 20. And then I solve. Sine of B is equal to 20 times sine of 40, all divided by 15. Do I want to reduce that? I don't know. I'm just going to plug it into Desmos. Hope for the best. All right, so I got Desmos here. Do some arcsine stuff. So I get, all right, after plugging this into Desmos somewhat successfully, I get B is equal to 59, 58.98696957. Okay, so I'm going to go 59. Okay, and that's one of them. But we can have another B here. So B is equal to, let's see, 180 minus this junk. Let's do 180 minus, and I get 121. 121. There we go. That's not bad. Yeah, it's not too bad. Not too bad. Moving on. New types of problems here, I hope. It says prove the identity. Okay, I got this. I like proving identities, I think. This one looks hard. Let's see, sine A plus sine B over sine of B. And we want to show that this is equal to A plus B over B. I'm kind of stalling because I don't know what to do here. Okay. Okay, let's see if I can figure this out. All right, so I do have the triangle, or not triangle, the law of cosines here. So I'm going to write it down and do some side work here. Law of sines, that is. Not law of cosines yet. So I guess I'm going to call this side work. And I know if I have sine A over A is equal to sine B over B. And then I was just like, okay, I want to solve for A here, right? So A is equal to, and the reason I'm solving for A is because I want that. So A is equal to B. Let's see, A is equal to, let's see if I can do the math here. B times sine of A over sine of B. Okay. I think I see something. Again, I like multiply both sides by A, and then I multiply by the reciprocal. That's why sine B went in there. Okay, so what I'm going to do to prove this, I'll start to the left. That was side work. I got sine of A. I kind of like this, I think. Sine of A plus sine of B over sine of B. And then I'm going to multiply by see, we got to think about this. Like, I have a sine of A, and I want to make this. I want to make this so I can have an A. So if I multiply by B over sine of B divided by B over sine of B, because we have to have the same thing, sine of B, multiplying by a factor of 1, and then distribute to each term. So you would get B times sine of A in my first term over sine of B. in my second term, I would just get b. When I distribute this, the sine of b's cancel out. In the denominator, I just get b. Because when I multiply that, it just, cancels out. And then we did the side work over here, which, I hope we understand this side work. We did the side work over there. That must be equal to a. So therefore, I get a plus b over b. Perfect. Yay. 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 I'm going to take it, dude. I'm going to take it as a win. Yeah. On to the next. Got a couple word problems. 10 minutes in. Get like 10 minutes to answer these 3 word problems. And we'll get it. Let's see. A fire is sighted from 2 ranger stations that are 5,000 meters apart. The angles of observation to the fire measured at 52 degrees. Okay, so I think there's like a tower here and a tower here, and then there's a fire. And then I think they're saying the angle of observation is 52 degrees. I think that's here, and this is 41 degrees. And it says the distance apart is 1 mile. Let's see, a fire site, 2 ranges that are 1 mile apart. Okay, 5,000 meters apart. Find the distance along the site to the fire from the closer station. Okay, let's see what makes sense. Okay, so I believe the smaller angle is going to give us the smallest side. So we want this guy. I believe that's true. It's like not opening up as much. And I don't want to call that X. I'm going to go like A. And this is the side we want. With a little bit of math, this is 93 degrees. So I believe this is 87 degrees. Hope that makes sense. So then I'll say sine of 87 degrees over 5,000 is equal to sine of 41 degrees over A, and then just solve for A. So A is equal to, this wasn't bad at all. A is equal to 5,000 times sine of 41 degrees over sine of 87 degrees. Done and done. Let's just make sure we get the right answer. I've been my track record lately hasn't been that great. 5,000 sine of 41 degrees over sine of 87 degrees. 3,285-ish. Let's see what the answer says. 3,280. Wow. Close enough. Close enough. I'll take it. Yeah, that's close enough. Sig figs. All right. A loading ramp 5 meters long makes a 25-degree angle with the level ground beneath it. The ramp is replaced by another ramp that's 15 meters long. Find the angle. Okay. I think I understand. So there's like a loading thing, and then there's a ramp, and it's 5 meters. And then there's going to be a new ramp. And this degree here is 25 degrees. Okay, and then there's going to be a new ramp. That's 15 meters long. So it's 15 meters long. And this is 15 meters long. 15 meters long. And they want to find the angle that the new ramp makes of the ground. So they want this theta. Wow, my picture's terrible. I hope that makes sense. Pictures not that great. Okay, I know this angle. This angle and the 25 are supplementary, which means if you add them together, they give you 180. So that angle is going to be 155, I believe. So yeah, I need to zoom this in. This is getting like too crazy. All right, so there's like, there's my original one where this is 5 meters. By the way, I feel like you could solve this with right triangle trig. And this is 25 degrees. And then we have, this is 15 meters. Is it 15? Yep. And I know this angle is 155. 155 plus 25 is 180. And then we want to find this angle, theta. I think we're done. I don't think this is going to be too terrible for us. But this will make a good example of like, here, I'll show you. So then we're going to say sine of 155 degrees over 15 is equal to sine of, I don't know why I'm calling it theta, but I'm going with it, theta over 5. Yeah, it's 5. Yep. And then we just solve for sine of theta. So sine of theta is equal to 5 times sine of 155 over 15 degrees. And then do inverse. And we get an answer. And that answer is, oh my God, hold on. Control Z, control, I had a formula up here. All right, so 5 times sine of 155 over 15. I got an answer of 8 degrees. 8 degrees. So 8.1 maybe. Let me double check.
I'm gonna make myself some chicken teriyaki.
Sure. Go for it. I got theta is equal to 8.1. Okay, so remember we had that like, you know, ambiguous case for sine. Like this can't be the ambiguous case. Like ambiguous case won't work, because this would be like the other angle would be 171.9 or something like that. But that's 171 plus 0.9, and this triangle already has an angle of 155, so it's definitely not going to work. So it's only like this angle here, but you got to be aware of that second possibility. All right, so 6. Okay. 123-foot support wire from a transmitting tower makes an angle of 61 degrees with the ground. Okay, this sounds really similar to the last one. This is 61 degrees. And this is 123 feet, but this is exactly the same. The wire is to be replaced by a new wire whose angle with the ground is 46. So if it's going to be a smaller angle, it has to be like 46. That's obviously a smaller angle. And so now it says, how long will the new wire be? Okay, so we want this. I guess I'll call it X. I don't know. Again, I can find this 61 minus 180, which would be 119, I believe. I believe so. 180 minus 60 is 120. And then we'll say sine of 119 degrees over X is equal to sine of 46 degrees over 128. And then I'm going to cross multiply and solve. So I get X. Did I say 128? Come on, that's 123. That's 123. Okay. I believe this works out to 149.6 when you throw this into Desmos. Anyways, there's a lot of sines. A lot of cosines. You don't really have that ambiguous case anymore because the interior sum of an angle, interior sum of the 3 angles of a triangle have to be less than or equal to 180, and cosines only positive in the first quadrant. It's like first and fourth quadrant, but that angles in the fourth quadrant are way too big. They're bigger than 180, so those don't work. All right, thank you.